The main components of a gear pump are a static casing, meshing gear wheels which rotate inside the casing, and a gland seal to prevent leakage of liquid. The prime mover is an electric motor, and these types of gear wheels are often called spur gears. Gear pumps are employed on board ships for the transfer of fuel and lubricating oils. Gear pump consists of two meshing gears enclosed in a casing. One gear wheel drives the other. As the pump rotates, the movement of the gear first removes all air in the system, thus creating a vacuum. This is because there is very little clearance between gear teeth and casing, which prevents backflow of the air. After all the air is expelled, liquid is drawn and pumped into the discharge pipe. The liquid is transported circumferentially between the casing and the gear teeth and not between the two gears. The main components of a screw pump are meshing helical screws, an external drive gear, thrust roller races, pump body, and gland seal. Like gear pump, the screw pump has screws instead of gears meshed together. Both the screw shafts are provided with gears. One gear will drive the other, which will turn the screw, since they are on the same shaft. These gears are also called timing gears. As the screws turn, the trapped air in between the screw is pumped out to the discharge side. Air cannot flow due to small clearances between the screw and the casing. This creates a vacuum on the suction side and liquid is drawn into the pump. Liquid that is wrapped around the screw and the casing is transported axially to the discharge side. Screw pumps are often used to transfer lubricating oil. It consists of a screw-shaped stainless steel motor, which rotates in a rubber stator having double internal screw threads. During rotation, the rotor tightens against the stator, and the enclosed fluid is displaced axially through the pump. The center line of the pump moves slightly radially during rotation. Rotor and stator engage in such a fashion that it provides uniform positive displacement throughout the length of the pump. Also, the rotor and stator form a tight seal that prevents backflow of the fluid. This type of pump is versatile, as it can be designed to handle a wide variety of liquids. It includes liquids that are more viscous, slurries, pastes, solids in suspension, and even delicate fluids, largely because of the low flow velocities through the pump. Heads of up to about 45 meters are possible for each stage employed. Multi-stage pumps of this type are also used for deep well services. Vane pump consists of cylindrical rotors with slots in it. The slots have vanes that can slide in and out. The rotor is positioned eccentrically to the center of rotation of pump casing. As the impeller rotates and fluid enters the pump, the centrifugal force of the liquid pushes the vanes to the walls of the housing. The tight seal among the vanes, rotor, cam, and side plate is the key to the good suction characteristics common to the vane pumping principle.